the chlorine gas. So first I'll talk about what the preparation of chlorine gas. Okay, fine. So mainly we prepare chlorine gas by a process called decons process. DEACONS, decons process. It's a very simple process. We just treat what HCl with oxygen in presence of CuCl2 as a catalyst. CuCl2, and then we heat it, delta, then we heat it. We'll get what? Chlorine and water. So if I want to balance the reaction, I'll be just giving what? 4HCl and 2H2O here, just to balance it. Okay, so this is a simple preparation of chlorine gas. Next thing is, what happens if the chlorine reacts with ammonia? Reaction with ammonia. This is my first thing. This is my second. Reaction with ammonia. So I'll write down here itself. So ammonia with chlorine. I will put here 3 because excess. More amount of chlorine. Okay. EXCESS, excess, will be giving me what? NCl3, nitrogen trichloride, and HCl and HCl. If I want to just balance it, I'll just put here 3. That's it. This is in case of excess of chlorine. So what happens if it is excess of ammonia? For example, ammonia I'm putting excess. I'll put excess ammonia and chlorine. I'll be getting ammonium chloride, NH4Cl and nitrogen. Again, if I want to balance it, I'll put 3 here and I'll put 6. That's all. So these are the 2 important reactions of chlorine with ammonia. Now reaction with NaOH. Reaction with NaOH. So what happens if chlorine reacts with NaOH? So I'll write down the reaction here. NaOH plus chlorine will be giving me what? Sodium chloride NaCl and NaOCl plus water. I'll write down what is NaOCl. It is sodium hypochlorite. Sodium hypochlorite. CHLORITE. Sodium hypochlorite. That is my NaOCl. Sodium hypochlorite. Okay, and just to balance it, I'll just put here 2. That's it. Okay, so this is in case of what? I'll write down here cold and dilute NaOH. Cold and dilute. So same thing if I put with what? Hot and concentrated NaOH, I'll write down next one. NaOH and chlorine, where here it is hot. NaOH is hot and concentrated. What I will be getting, I'll just show you. So you'll be getting what? NaClO3. The rest of the things are same. NaCl and water, we will be obviously getting it out, but we will be getting NaClO3. That is nothing but sodium chloride. Sodium. This is nothing but my sodium chlorate. Fine. Yeah. And coming to the oxidizing agent, how chlorine gas acts as an oxidizing agent. Okay. So chlorine with water will give me what? HCl. I'll write here 2HCl plus O. So what happens is that if I put any colored substances, if I put any colored substance with this oxygen thing, I'll get what? Colorless substance. Colorless substance. So this is the key takeaway from this. And next thing is bleaching agent. Bleaching agent. So calcium hydroxide, that is CaOH twice, in reaction with what? Chlorine, will give me what? Bleaching powder. CaOCl twice. That is my bleaching powder. CaOCl twice. Okay. I'm not writing the entire thing. After this, I'll write it what it is. Plus CaCl2 and water. So the CaOCl twice is my bleaching powder. So how do you write this bleaching powder basically? What is the composition of this bleaching powder? I'll write as text so that here, yeah, this is fine. Composition of bleaching powder. Same thing, you don't put plus. Okay. In the sense, I'll write down here CaOCl twice, correct? Dot. Instead of plus, I'll put dot. CaCl2 dot H2O. So suppose you want to balance this, I'll put here 2H2O. So the same thing I'll put here also. Dot 2H2O. So this is my composition of bleaching powder. So later on, I'll be sending this as a PDF of the notes, so no need to worry. Not a screenshot, as a PDF I'll be sending to you. Okay. Yeah. And then you have to study the use of chlorine gas, which I'm not going to write. So it can be a tear gas and all of those things. So that I'm not going to write here. Fine. Now coming to another important thing, HCl. Very important. Hydrogen chloride gas. Okay. One of the most important property of this is what? It is colorless and it is a pungent smelling gas. Very important. We'll just leave it like that. But for the entrance, they can ask pungent smelling gas. So when it is called HCl acid, hydrochloric acid, hydrochloric acid, hydrochloric acid, when it is called I'll write down here hydrochloric acid. This is my gas basically. When it is called hydrochloric acid, if it is in aqueous solution, if this gas is in aqueous solution, then it is called hydrochloric acid. Then one more important thing, aqua regia. I'll tell you what it is. Aqua regia. So it is nothing but it has got three parts of HCl, concentrated HCl, and one part of concentrated nitric acid, concentrated HNO3. So what is the purpose of aqua regia also I'll tell you. Okay, so it is used for dissolving noble metals. Use of this, use to dissolve noble metals. So we all know what is noble metals, gold, platinum, and all of those things, right? Noble metals. Okay, so what we do in this, we take three parts of HCl concentrated plus one part of HNO3. This will be getting as what? We'll be getting water and NaCl and 2 chlorine. Fine. This is the aqua regia thing. Yeah. Now coming to the next one. Oxo acids of halogen. So I'll write down here oxo acids of halogen. So HClO4, then I'll write HClO3, HClO2, then HClO. I'm just reducing the oxygen molecule in each and everything. So first thing is acidic strength. So there are three things in this. One is acidic strength. Next one is oxidizing power. Oxidizing power. Okay. So in both the things, I'll tell you. I'll just write it down. The HClO4, then HClO3, HClO2, and HClO. So similarly, I'll write here also HClO4, HClO3, HClO2, and HClO. The only thing which we want to know is what? Greater than or less than. For this thing, everything is greater than. Acidic strength. For this, everything is less than. And coming to the stability of the ion, one more important thing. Stability. Stability of what? Stability of the ion. There is ClO4 minus greater than ClO3 minus. greater than ClO2 minus greater than ClO minus. So this is the stability of the ion. So this also is saved in as a PDF. Okay. Yeah. So suppose if we couldn't take screenshot, I'll be forwarding the thing. Now coming to the next one, interhalogen compounds. Interhalogen compounds. So the meaning first you have to understand interhalogen, the sense combination of two different halogens. Combination of two different halogen. So I'll write down the various uh, combination. Okay, XX dash, yeah. So XX dash 3, XX dash 5 dash shows different halogen. Okay, XX dash 7. This is 1 3 5 7 shows the oxygen states, which I discussed in the last class. So basically what I will tell you is, if you ask me what is X and X dash, I'll tell X is the halogen of larger size. Larger size. X dash is the halogen of smaller size. Okay, just to give you more insight. And one more thing I'll like to tell is, add is, X is more electropositive compared to X dash. This is my X. It's more electropositive compared to X dash. Okay, and coming to the properties of these things, fine. First important thing, they are all diamagnetic in nature. Diamagnetic in nature. In the sense there is no unpaired electrons. So paramagnetic in the sense there is a presence of unpaired electron. Diamagnetic, all are paired. That's it. Okay. So next important one. I'll write down an exception here. Except CLF. Except CLF, every other combination of the two different halogen is either solid or liquid. Solid or liquid, except this combination. And one more thing is, third one, this XX dash bond is weaker compared to XX bond, in what halogens? In halogens. So even if I say this thing, is there an exception in this? Yes, there is an exception in this also. That I'll write it down here. There is an exception in this. Except FF bond. In FF bond, what happens? Yes. Except FF bond, all other XX dash bond is weaker compared to the XS bond. Listen, CL. So all of these things, it is weaker. Okay, XX dash bond is weaker compared to the XS bond, except this FF bond. FF is nothing but XS only.